The tutorial was written by Eliana a couple years ago, and then there's been a couple iterations over the course of a couple years for Intro2Astro. Just as a little bit of background, so my name's Isaac. I'm a grad student at University of Michigan. My work, like every single day, I use pandas. Like at the top of every Python document, I have import NumPy, import pandas, import matplotlib. So these things all go really, really well together, and they kind of make up the backbone of a lot, or at least of a lot of graduate student astronomy. I don't know what it looks like at different levels, but like my work every single day, anytime I have data that I need to analyze or like look at or any kind of thing with data, it's pandas, NumPy, and matplotlib. Um, so I'll be going over pandas today. Yeah, there's some interesting info about like how pandas interfaces with Python and how it's a package and all that stuff, but I'll get right into how to use it mostly. But feel free to go through and read this stuff. And also, I think the best way to learn how to use these is not just to watch tutorials, but to go through and try it yourself. So everything I'm saying today is just a very, very small section of how you could use pandas. So like, you know, if I have a dictionary and I have 5 things, I recommend going and trying it on your computer and trying it with like different dictionaries, different elements. There's tons and tons of resources online. So don't feel like you just have to follow exactly what I'm doing here. This is directly from the Intro2Astro GitHub. So please follow along if you have that downloaded. So first, I'm going to import the following things: NumPy, pandas, and matplotlib. I just shorten them so it's like MP and PD and PLT, just so when I'm coding, it's a little bit easier to read. And these are just standards, and sometimes people have slightly different stuff, but this is just a different way of calling these libraries. So first, what I'm going to do is create like an example dictionary. So what pandas is really good for is the back end data management. So let's say you have like a CSV file or a text file, and you have different like elements, and you want to create a data frame out of it. That's what pandas is really known for and best for. So I'm going to create a data frame where I have a list of names, a list of birth counts, and a list of percentage births. These are all just example things. They're not particularly useful, or they're not particularly important for what they are. So just to give an example, I have the type of each one of these. You can see like the type of the list names is a list. Other stuff like birth count. You can see now it's saying both names and birth count are lists. So with these 3 lists, I'm going to create a dictionary called data. So data will have names with the list names, count with the birth count, and percentage. So you can see it's a dictionary, and then when I print it out, I have this information. So now I'm going to make a data frame out of that dictionary. So dictionaries are another element in Python. They're very helpful, but you don't need pandas for dictionaries. But this is turning the dictionary into a pandas data frame. So now just to see what we've done, I'm going to print out the pandas data frame just with df.head. As you can see here, this is the pandas data frame right there, and it's being printed out with the command head. So head returns the first n rows, where n is 5 right here. You can always Google these commands and see how they're being called. So let's say I wanted to print out the first like 2. You could see it shortens it. And so it has column names, count, and percentage. And then this is the index. So like the number row that it is. It always starts at 0. One powerful thing you can do with pandas is to save the data frame that you're working with in different formats. So if I was going to do df.to_csv, and then this is the file name. So what this command is saying is take the pandas data frame that you have here, df, and then use the command to_csv to save it. So the df right here is from the data frame itself. Df doesn't specifically mean like data frame. It's just what we saved it as up here. So if I had saved that as like random equals this, if I was doing that, I would then change this to like test random name dot to. just to show you how like this type of command structure works. And so what this is doing is it's going to save the pandas data frame with the name save the pandas.csv, and will be in the folder that you're currently running this file. So that means that like if this file is like within your Intro2Astro folder, it will save that CSV in the same folder. If you want to change it, you could change it to like users. So that would give the absolute path that I'm saving it to if I wanted to save it to the desktop. But for now, I recommend playing around with that stuff. But this ties into the Unix demonstration that you were given on the first couple of days, that it's important to understand kind of the back end for all of the stuff and where these files are and where they're getting saved. Cool. Another thing that's very helpful with this stuff is you can take these data frames and not just save them as to CSV. I know the command is to CSV, but you can also save it as like a text file, and that can be really helpful. And then there's tons of other stuff that you can use. Every time you have one of these commands, you can look up the options for what's possible. So let's say I have this data frame and I want to change how the resulting data is saved. With this, it would be saved with commas, but I can also choose to have the separator be a blank space or even just a random letter. And anytime you have one of these, you can look up the docs just to show you what the options are. So this is like read CSV, and it will show you there's actually tons and tons and tons of options to use that command. And this gets really powerful if you have a document that you want to read in, but it has like very confusing ways of like saving the data. I've used this tons and tons of times when I have a document with like different white space that I need to read in. Pandas will let you read in a ton of this stuff with a lot of power, rather than just trying to like retype the data or figure out a different way in Python. Pandas is very, very well equipped to read in different data. Cool, so next I'll move on to a little bit about data manipulation. This is another thing that Pandas is great at, is to quickly perform operations on large data sets. So let's say I'm making a new data frame just with the columns 1 and column 2 that I'm calling X and Y. And I'm just creating them with random numbers between, you can see random numbers here. And now I'm printing out the data frame here just in the same way. Pandas can use these columns and these numbers to perform very quick operations. So you can see if I have X and Y, I now create a new column that's just the sum of X and Y, or another column that's just the product. So you can see here. This could be helpful, let's say if you have a table of exoplanets and you have like the value of the exoplanet mass in Jupiter masses and you want to convert it to grams, you can then very, very quickly just do that with pandas by multiplying by a constant. Cool, so now I'll get into slightly more complicated stuff with pandas. For this, you're going to need to read in the CSV baby names, and you can get this just by going to the Intro2Astro site, which you can see here, babynames.csv. So there are a few ways that you can explore what's in your CSV file. For example, you can see what columns are included, you can look at the first few lines, or you can see how many rows or items there are in the data frame. I recommend either doing this by reading it in Pandas and Python, or just looking at the document in like a text editor. This is something that I do every time I get new data, is try to figure out what's the best way to understand it holistically. So you can see, I'm going to read this in, and then I'm going to print out the column names. And this says that the column names are year, name, percent, gender. And I'm going to print out the first 10 rows of the data frame itself, like this. As you can see, this is what the read in Pandas data frame looks like. You can also see, if I print out the length of the data frame, it has 258,000 rows, so much more than you'd want to read by hand. Now we can start analyzing the Pandas data frame itself. As you can see, I'm isolating a column, including the information about each year, and then printing out that column, which will return a series. You can see right here, this is just saying the type of that structure, and that's a Pandas series. Now I'm finding the minimum value in that column using the .min command. like this, which is saying, okay, search that Pandas series and find the minimum value within that. So let's say I wanted to change that. I could do print max. So that would say that the maximum of that Panda series is 2008. And you can do all kinds of stuff like this. This is a great way to figure out the type of data that you're dealing with. Oops, I think I would need to do like use NumPy for that. Oh, typo. I've done this type of stuff for years and years, and I still, when I'm coding in front of people, it's always very stressful. But you'll understand after you do a bunch of this stuff. It's like my coding skills drop by about 10 years whenever I'm doing it in front of other people. So now we can look at different ways of manipulating this data set. You can see I'm calling the column percent in the names data frame, and then printing out the mean, the median, and the mode. So you can see this is just different ways to analyze the statistics of the data set. And now you can also see, let's say I had name. Yes. So this is just showing you, oops, what the data frame looks like again. If you want to select different rows or different elements within that data frame, Pandas is really, really powerful to be able to do that. So I'm going to create a subset of that Pandas data frame by using the .lock command, or LOC. So this is just trying to locate it. So I'm selecting every row where the year is greater than 1960 and the year is less than 1970, and also that the gender column is returning a girl. So you can see if you look at this Pandas data frame, it will select only the rows that satisfy both of these conditions. So both that the years between 1960 and 1970, and also that the gender is girl. And this is a really powerful way of sorting and selecting your data, that if you have different stuff like this, you can select only the names that you want, only the years. This becomes really, really helpful if you have a huge data frame. That Pandas is great with these Boolean operators for selecting stuff. So now that I run that, now I have a separate Pandas data frame of subset. So you can see subset. So it's only selected the subset of that original Pandas data frame that followed these conditions. So if you had a year that was outside 1960 to 1969, you would know that this original command didn't work. And now we can sort that subset data frame by percent. So this should return the most, the highest percent down to the lowest. You can see here. You can also tell that there are other ways when you sort this. You can sort it by more than just one row. So let's say I had a percent, and then I also wanted to sort it by year. You can do all sorts of combination commands. So you can see like sort values. Again, you can see the different types of commands that you can use with sort values in order to return the Pandas data frame that you want. So now last, there's an assignment and a challenge assignment with Pandas. So first, can you make a histogram by the percentage popularity of the name Lisa during the 1960s? Can you make a histogram of the percentage popularity of the name Mary during the 1960s? Now can you plot them on the same histogram? So in order to do this, you'll have to combine what you've learned about Pandas as well as what you've learned about matplotlib and all these things. So also, I didn't mention it because I was running out of time a little bit, but you can use Pandas to interface really, really well with NumPy and matplotlib. That matplotlib.pyplot, you can call directly with the Pandas data frame series. And last, if you're feeling like you really, really want a challenge, you can try this challenge assignment, which will be a much more complicated way of using Pandas. Cool.